Hello everyone. This video will cover parallel and perpendicular lines, also creating linear equations. Okay, so starting off with parallel and perpendicular lines, these can be found by remembering one very important thing. Well, two very important things. First is that m equals y2 minus y1 over x2 minus x1. Okay, remember that m is your slope. So basically this is the slope formula that we went over in our last video. And if you remember, y equals mx plus b. Remember, that's the slope-intercept form. Okay, so for example, if you have y equals 3x plus 8, we can see here that your slope is m equals 3, and your y-intercept is 0, 8. Remember, your b is equal to 8, so it's 0, whatever that b value is. All right. So let's say, for example, also, if you have, let's say, two lines that never, ever, ever intersect each other. Okay, let me start a new sheet here. Okay, so if you have two lines that never intersect, so if you have two lines that never intersect, and all that means is just they never cross each other, then they are called parallel lines. Okay, so for example, well, actually, before I put the example, let me put one very important thing here. If you have two lines that never intersect, that is really just a fancy way of saying they both have the same slope. Okay. If two lines have the same slope, then they are parallel. To each other. Okay, so this is just another way to say this. Okay. Now, if you want to visualize parallel, let's say if you have a graph and this is your first line and this is your second line. Okay, those are parallel to each other. They're going in the exact same direction and they're never, ever, ever going to cross each other. Or what if we have these two lines? Okay, those are parallel, go in the same direction, and no matter if this goes on forever and this one goes on forever and this goes in that direction and that direction, they'll never, ever, ever cross each other, no matter how long they become. Okay, same thing here. Let's say if you have two lines there, no matter which direction they're going, these two lines are parallel to each other. They have the same slope. They're going in the same direction. They're never, ever, ever going to cross each other, no matter how long you make them. This one can go on forever. This one can go on forever. They will never cross each other. Okay, so these are parallel. These two are parallel, and these two are parallel. Okay, so let's say, for example, okay, we know how to look at a parallel line visually, but what if we wanted to figure out if two equations are parallel? Okay, so let's say if we wanted to determine if y equals 3x plus 4 and y equals 3x plus 2 are parallel. Okay, honestly, that one's pretty straightforward, because if you have y equals 3x plus 4 and y equals 3x plus 2, all you have to do is look at the slopes, because they're already both in slope-intercept form. They're already in y equals mx plus b form. Okay, so if you look at this here, you know that your slope is equal to 3. And if you look at this one, your slope is equal to 3. Okay, so right up here it says if two lines have the same slope, then they are parallel to each other. So we know that these two are parallel. Okay, so they are parallel. Okay, like I said, pretty straightforward. Let's say for our next example, what if we wanted to determine if, let's say, y equals 7x plus 9 and 7x plus y equals 9 are parallel. Okay, now this one is a little tricky, because if you notice, this is in slope-intercept form. Y equals mx plus b. This one is not. So if you looked at this and automatically thought 7x and 7x, oh, they're parallel, you would have gotten this one wrong. You have to be really careful before you can determine if it's parallel or not. You have to put them all to the point where y equals mx plus b form. Okay, that's a very, very, very important first step. Okay, and it's the same thing for perpendicular when we go over that. You have to put it into y equals mx plus b form before you can tell whether or not they're parallel. Okay, so let's move that up a little bit. Okay, so we have y equals 7x plus 9. And here, if we subtract 7x from both sides, minus 7x, minus 7x. Okay, those two will cancel out. So you end up with y equals negative 7x plus 9. Okay, now if you looked at the original problem, you would think, oh, 7x and 7x, they're parallel. But if you do it correctly, you'll notice that this slope is equal to 7. But this slope is equal to negative 7. That's where you have to be really, really careful. Okay, so they're all both in the y equals form, but they are completely different slopes. Okay, so we can see here that because the slopes are different, these are not parallel. Okay, so let me put that. Not parallel, because your slopes are different. Okay, where we know here it's parallel because slopes are the same. Okay, so hopefully that made sense. All right, so let's go on to our perpendicular line. Okay, to solve for perpendicular lines, once again, you have to put them in the y equals mx plus b form, but you're looking for something a little bit different for perpendicular. All right, so let's go to a fresh sheet of paper. There we go. Okay, now if two lines meet or intersect at a 90-degree or a right angle, then they are perpendicular to each other. Okay, so what that means is if you have two lines and if they meet like this, okay, these two are perpendicular. Okay, so let's say if you have line 1 here and line 2 there, they're perpendicular. Okay, if they meet at they have a perfect L right there or a right angle, they're perpendicular. Okay, now we know what they look like when they're graphed. To figure out whether or not two lines are perpendicular to each other and you're given just the equations, you have to look for two specific things, okay? And before we go over those two specific things, we're going to go over a really quick definition. Okay, so two values are reciprocals of each other when their numerator and denominator are flipped, you can say. Okay, so the actual definition is when you multiply them together, two reciprocal values, their product equals 1. But in this case, we just need to know that they're flipped. Okay, so for example, let's say 7 over 8 and 8 over 7 are reciprocals of each other. Okay, so all you did was get the 7, 8 and the 8, 7, and you flip it. Also, let's say 2 and 1/2 are reciprocals. Okay, and the reason for that is that 2 is the same as 2 over 1. So if you get 2 over 1 and you flip it, you get 1/2. Okay, so these two are reciprocal. So 1/2 is a reciprocal of 2, and 2 is a reciprocal of 1/2. Okay, so I want to get that definition. Make sure you remember that. It may have been a while since you've seen it, but I wanted to refresh your memory for reciprocals before we get to the steps for finding out whether or not two lines are reciprocals of each other. I mean, not reciprocals, are perpendicular to each other. All right, so two lines are perpendicular if, okay, first thing, their slopes have to be reciprocals of each other. Uh-oh, clean that up a little bit. Okay, so that means their slopes has to be reciprocals of each other, and both of these have to be met. B, their slopes have different signs. Okay, so as long as those two criteria are met, you'll know two lines are perpendicular. Okay, when those two are met, this is what they call negative reciprocals. These called okay. So sometimes you may see a book refer to finding the negative reciprocals. That just means both of these criteria have been met. All right, so let's go on to a few examples. Remember, if you're still writing, feel free to press pause. Okay, bring that. Okay, so let's say, for example, if we want to determine if y equals negative 7x, let me clean that up a little bit. There we go. Negative 7x plus 15 and y equals 1 over 7x plus 87 are perpendicular. All right, so really with this one, we have y equals negative 7x plus 15, and we have y equals 1 over 7x plus 87. Okay. Now remember, for parallel and perpendicular, we're not too worried about the y-intercept. Had a little brain freeze for a second. We're not worried about the y-intercept. We're just looking at the slope when we're talking about parallel and perpendicular. Okay? So we know that y is equal to, well, the y slope is equal to negative 7. And for this one, we can see that the slope is equal to 1 over 7. Okay, so we can see here one's negative and one's positive. Okay, so we can also see their reciprocals. You got 7, which is 7 over 1, you have 1 over 7. So the slopes are reciprocals of each other. And the signs are different. Okay, so as long as both of these are met, we're good here and we're good here, so they're perpendicular. All right, so now let's look at, move that down a little bit in case you're still writing. Go to our next example. Okay, now what if we wanted to determine if y equals 3 over 2x plus 9, and actually let me mix it up a little bit. Let's say 2x plus 3y equals 21 are perpendicular. Okay, so we want to determine if this line and this line are perpendicular to each other. Okay, now remember, they have to be in y equals mx plus b form. Okay, now the first one, we're okay there because we have y equals 3 over 2x plus 9. So that one, we're good because we know that the slope is equal to 3 over 2. Okay, so we're all right there. The one we have to do a little extra work is 2x plus 3y equals 21. And that's because we have to get the y by itself. So we subtract 2x from both sides, where that cancels out. Okay, so we have 3y equals, remember, we're going to put the x term first, so that's negative 2x plus 21. Okay, so now we divide each term by 3 to get that y by itself. Anything divided by itself is just 1, so that just becomes 1 times y. So we have y equals, remember, we can bring that x and put it in front. We have negative 2 over 3x plus 21 over 3. Okay, so now that we have solved for y, we know that the slope is equal to negative 2 over 3. Okay, so now that we can compare both of our slopes, we see here we have 3 over 2 and 2 over 3, so they are reciprocals of each other, and the signs are different. They are reciprocals, or the slopes, let me say that instead of they are. The slopes are reciprocals and their signs are different. So they are reciprocals. I mean, they are perpendicular. All right, so hopefully this is all making sense. All right, so let's say if we have an example that looks like this. Okay, so determine if 7x plus 3y equals 1 and negative 3x minus 7y equals negative 7 are parallel, perpendicular, or neither. Okay, because it is possible to not be parallel or perpendicular. Okay, so no matter what, we're going to have to put both of those in y equals mx plus b form. So basically solve for y. Okay, so we have 7x plus 3y equals 1 on this side, and negative 3x minus 7y equals negative 7 on this side. So we're going to solve for y. Okay, so if we subtract 7x from both sides here, that cancels out. So we have 3y equals negative 7x plus 1. So now we divide each term by 3. 3 divided by 3 here cancels each other out, so that becomes 1. And that gives us y equals negative 7 over 3x plus 1 over 3. All right, so we solve that one for y. Now we do the same thing here. So we add 3x to both sides there. Well, those two cancel out, which gives us negative 7y equals 3x minus 7. So if we divide each term by negative 7, those negative 7s cancel out. That leaves us with y equals, you can have negative 3 over 7x. Remember, the negative in the denominator, you can move that out to the front, or in the numerator, you can move that one out to the front. Same thing. Negative divided by negative is positive, so you have plus 1. Okay. So now we just compare our slopes. Here, the slope is equal to negative 7 over 3. But here, our slope is equal to negative 3 over 7. Okay, they're not the same, so we know they're not parallel. They are reciprocals, but the signs are not different. The signs are the same. Remember, for them to be parallel, they have to be both reciprocals and the signs are different. Okay, so because the signs are the same, we know it's not parallel. Well, they are not parallel. Okay, not parallel since these slopes are different. Okay, not perpendicular since the signs are the same. Okay, so the answer is neither. Okay, it's not parallel, it's not perpendicular. Well, they're not parallel to each other, they're not perpendicular to each other, they're neither. All right. So hopefully that made sense. Okay, so let's do one more example of parallel and perpendicular. All right, so let's say, for example, determine if y equals 3 over 4x plus 3 and 8x plus 6y equals negative 5 are parallel, perpendicular, or neither. All right, and what I want you to do is press pause and try to work this one out for yourself. All right, so I'm assuming that you have already pressed pause, work this one out for yourself. So let's go ahead and verify your answer. Okay, remember this one's already in y equals mx plus b form. Okay, so you have y equals 3 over 4x plus 3. So here we already know that the slope is equal to 3 over 4. Okay, now this one, 8x plus 6y equals negative 5. We're going to go ahead and subtract 8x from both sides, where those two cancel out. So you have 6y equals, remember your x term goes first, so negative 8x minus 5. Now we're going to divide each term by 6. Anything divided by itself is 1. So we have y equals negative 8 over 6x minus 5 over 6. Okay, now remember, 8 over 6 can be simplified. So we're going to move that up, and we'll see that 8 over 6, remember 8 is just 2 times 4, and 6 is just 2 times 3. Okay, and those 2's cancel each other out. So you're left with 4 over 3. So that negative 8 over 6 becomes negative 4 over 3. So we have y equals negative 4 over 3 minus 5 over 6. Okay, so now that we have that simplified, we know that slope is equal to negative 4 over 3. Okay, so if we look at it, they're not exactly the same, so we know it's not they're not parallel to each other. But if you look at this one, you have 3 over 4 and you have 4 over 3. So we see that they're reciprocals and their signs are different. So because they're both reciprocals of each other and their signs are different, we can see that they are perpendicular to each other. So instead of the lines are perpendicular since they are reciprocals. But the slopes, let me put instead of the slopes reciprocals, and that's the key, both of these have to be true. Their signs are different. Okay, so they are perpendicular. All right, so hopefully this has made sense, and I will see you on the next video.